Hi, my name is Aaron F. Ross, also known as Dr. Yo. If you see the username DRYO, then that is probably me. I'd like to share a little bit of my experience and what I've learned about video synthesis tools and techniques. And in this first video, we'll start with the LZX Industries Proc module, PROC. It's described by LZX as a triple voltage processor and summing amplifier. And as we'll see, that one-line description is accurate, but it doesn't really give a sense of all the amazing things that you can do with Proc. And if you haven't already seen the existing official training video by Johnny Woods, you might want to take a look at that. Johnny Woods was absolutely right when he described Proc as the indispensable module. And that's because it's the most versatile. Now, of course, if you want to get legal video out of a modular system, you need an encoder, like ESG3. And if you want to get legal video into a system, you need a decoder or a time-based corrector. But aside from those essential input-output modules, Proc really is the indispensable module because it's the most versatile. And at only $259, it gives you the most bang for your buck. It's the most value for your money. And because it's only 8 HP in width, it packs a huge functionality into a small space. And Johnny Woods was again absolutely right when he said that you need 2 or 3 of these for a functioning video synthesizer. Now, I've currently got 2 of them, but I also have an access module from Foxing Hour, and that gives the processing capabilities of Proc without the summing or adding and subtracting part. So you could say that I have 2.5 Procs. Now, on the topic of similar modules, Proc is directly descended from the LZX Expedition Series module called Passage. They're almost exactly identical. So everything that I talk about here in this demo will also apply to Passage. Here's a rundown of some of the amazing things that you can do with Proc. I certainly have not exhausted all the possibilities. These are just the things that I immediately have come up with in my initial journey. So Proc, at its most basic level, can be used as a buffered mult. You just plug one signal in, and due to the internal normaling of the 3 channels, you can get 3 identical copies of that signal. And of course, because it's a voltage processor, you can adjust the knobs and get variations on that signal. So instead of 3 identical copies, 3 different copies. Even without any incoming signal plugged in, Proc can be used as a static voltage generator, similarly to the LZX MAT module, which is optimized for just that function. Proc can do it too. And those static voltages can be combined in an RGB workflow to create a color picker. You can choose any color within the RGB color space. Proc can attenuate any incoming signal, reducing its value, whether that be a video image or control voltage. Proc can invert incoming signals. That means to make a positive voltage negative. And so you can get cool effects, like a photo negative effect. To do that, you need to combine it with the bias or offset function. But the bottom line is that you can invert any signal. And additionally, that means you can also subtract. So as we'll see, you can use Proc as a sort of a VCA. It's not a voltage-controlled amplifier in the strictest sense, but you can use it as a voltage-controlled attenuator. You can subtract things out of a signal. You can create a mask. Proc can offset a signal, biasing it up or down. And that sounds boring at first. So what? I can bias a signal. But it's actually crucial in a lot of use cases. In the one I just described, for example, if you want to create a negative of an image, then you need to be able to bias it up or down, because the attenuverter will invert this signal. That'll push it into a range of 0 to -1 volts. But an encoder cannot accept that. The LZX ESG3 encoder, for example, requires signals between 0 and +1 volts. And it'll just discard everything that's not in that range, just not even see it. So to get a negative, you need to invert the signal and then bias it up into the positive range. The summing part of the phrase summing amplifier is quite literal. It means that Proc can combine two sources per channel. And those can be video images or control voltages or any combination. And adding and subtracting is super important in many contexts. So one of the classic examples is pre-processing a video signal, adding or subtracting to it in order to sort of prep it or control it before it gets plugged into some other module that does not have an attenuverter or does not have a control voltage, scaling amount. So for example, the classic Sandine function generator just has an input and output. If you want to change the behavior of that, then you can modulate the signal before it goes into the function generator. That's just one example. And if you take the three independent channels of Proc and patch them to one another, daisy chain them, then you can turn Proc into a versatile mixer. Take the output of one channel, plug it into the input of another channel, and then you can add something else. And do that a few times, and you can combine up to 4 different signals. Last but certainly not least, Proc is a full-blown colorizer. So here are a few examples. You can take the red, green, and blue channels of a video signal and add them together in Proc and get a customized grayscale. Maybe you want to emulate a certain black and white film look. You can do that with Proc. Or you can take a grayscale image and colorize it. You can take a black and white picture and tint it to 2 different colors of your choosing. Or best of all, you can take RGB into Proc and RGB out of Proc and completely mess with the RGB video signal. Biasing, inverting, or cross-patching channels in any number of ways, and really going insane with those creative possibilities. So what's the deal with the name, Proc? What does that mean? Well, it's a reference to a piece of video gear called a Proc amp. That's the colloquial name for a processing amplifier. And a Proc amp usually lets you control the core features or properties of a video signal, namely the gain, which is the dynamic range, sometimes called the contrast. It's the overall amplitude. A Proc amp lets you control the black level, which is sometimes known as the setup or pedestal, and that's simply the offset. It's the bias. A Proc amp also lets you control the saturation or intensity of color, and the hue or phase or tint, which allows you to rotate the whole color wheel. So the LZX Proc module doesn't do all those things. It doesn't deal with saturation directly. You can reduce saturation, but you can't reduce saturation independently of the gain. And you also can't affect the hue using the Proc module. But Proc does a lot of things that a standard processing amp doesn't do. You certainly can't do the crazy colorizing. You can't add signals. You can't subtract signals using an ordinary Proc amp. All right, let's talk about the mathematics of Proc. It's really basic, Algebra 1, nothing to be scared of. We're just going to do a little bit of addition and multiplication here. So Proc has 3 independent channels. We've got channel 1, 2, and 3. And they are color-coded, red, green, and blue, but of course, you don't need to follow that. You can patch in whatever you want. It doesn't have to be an RGB signal. And for each independent channel, we're going to perform a basic math operation. We're going to take the jack A here and then add it to the product of jack B multiplied by knob B. Take that result and add it to knob C. Okay, so again, it's A, jack A, plus the product of jack B times knob B added to knob C. A plus B plus C. Simple enough. And then, of course, we have internal normaling, like all the Gen 3 modules. We can see this line here joining these inputs that indicates an internal normal connection. So if you plug something into the red jack, that will flow into the green jack and the blue jack. If you plug something into the green jack, that will flow into the blue jack, but not upwards into the red jack. Cool beans. All right, so let's see what we can do in terms of patching. The simplest and most basic patch is with no input, simply an output. All right, let's try that. I'm going to plug in to the red, green, and blue outputs here. Starting from the bottom is always easier. And with nothing going into the inputs, we can see what happens if we adjust these knobs. Let's try first the gain of the B input. Nothing's happening. Well, of course, since we have nothing plugged into B, we're multiplying by 0, so we're getting no result. But we're also adding this C knob. And as I bring that up, boom, we can see, aha, we're getting red. Okay, because I have these outputs plugged into an ESG3 encoder. And likewise, we've got green and we've got blue. Brilliant. And just like the Pink Floyd song, we can get any color you like. Love it. And the one thing about this is that we can't go negative, right? The encoder can't accept a negative voltage. So if we bring these down into negative land, we will just get black. And that means, of course, that we only have half the range of this knob. Only half that range from 12 o'clock to, approximately 5 o'clock. That's the usable range of these knobs. If you get the LZX matte module, you'll get the full range of the knob from 0 to 1, with 0 at about 7 o'clock and 1 at about 5 o'clock. So matte is really specialized as a color picker, but Proc will accomplish that goal just as easily. It's just not optimized for it. All right, so there's our color picker, easy enough. Moving on, what if we just plug something in here? I've got a luminance signal that I'm deriving from the Synth VU003B decoder. I'm going to plug that into the red, or number 1 input. And this is the patch of a buffered mult. Whatever I plug into this top input here, the red input, is going to flow to the outputs. But that's always going to be added to these knobs here. So if the knobs are at exactly neutral, then we will get a buffered mult. But unfortunately, exactly neutral in the analog world is kind of fuzzy and weird. So you can see here that these arrows are not pointing straight up, but I'm getting a more or less monochrome result, again with these red, green, and blue outputs patched into my encoder. You actually won't be able to get a buffered mult unless you play with these values and get them to actually output the same value. That's a little bit tricky. And that brings up the point, as always, that you should know your ABCs. Always be calibrated. Anytime you're doing video synth work, you should always be looking at a vector scope and or waveform monitor to check your system and, get a reality check, a sanity check on whether you're getting what you think you're getting. Because monitors, video monitors are all different, and that's not a good way to work. So anyway, I do have a waveform monitor and vector scope running, and I can see as I adjust these values that I'm actually changing the tint of the color, and I can dial in exactly a monochrome value by looking at the vector scope. All right, so that's a buffered mult, but those knobs are not straight up at the 12 o'clock position. Now, additionally, these bias knobs do not have a détente position. There's no center notch, but that's okay because that gives us a little bit more precision here. We can actually dial in something a bit more precisely than we would if there was a détente position. Now, these gain knobs do have a détente. They kind of snap in. It's very satisfying when that happens. You click, oh, okay, we're right at 0 now. All right, moving on, let's look at a different patch. What if instead of going into the A top input, we went into the B top input with this luminance signal that I've got? All right. So then, with the RGB outputs patched into the encoder, we can now see how we can achieve the tinting effect. We're going to colorize this. So if these knobs are all put up to their maximum, I'm not attenuating and I'm not inverting. But if I bring them down, if we bring them into the negative zone, you'll see that we get black. And that's because we are inverting that signal, and it's now outputting a negative voltage from those outputs. And we can't actually do that. We can't take a negative signal into the encoder. But if we increase these guys, bring them up, bring those biases up, then we're able to get a negative. Now, this is a black and white negative in this case. I'm just taking the luminance and patching it to red, green, and blue, and inverting all of those red, green, and blue equally. But of course, we don't have to do it that way. We can play with these and actually colorize the signal. So just mess with it, see what happens. And we can actually choose two different colors here in this process for the black and the white. But as we play with this, we will see that not only do we get those black and white colors, but we get everything in between. So we're actually able to get a full-blown colorizer by just patching in a luminance. Technically, we're really only getting two colors, but those two colors are blending in magical and wonderful ways. All right, very cool. I've actually got this patched up so that we can compare this colorized version to the original RGB version of this image. So I can just do a little wipe here. We can reveal that. We can see that we've really radically changed the color. All right, so that's taking advantage of the internal normaling, taking a grayscale image and turning it into full RGB. What if we take the RGB signal? Let's try that. Got that ready here. We'll plug that in. Here's the original RGB signal. Blue, green, and red. And as I patch that up, we'll start to see a similar result, but not exactly the same result. Even though I haven't changed the positions of the knobs, we're getting different colors, and that's of course because we're applying different signals. We're not giving the same luminance value to all three channels. We're giving three different values, red, green, and blue channels of the original image. And now we can really get some quite exciting results here with just a couple twiddlings of the knobs. We get an amazing possibility creatively. And this is just putting red into red, green into green, and blue into blue. We can, of course, mess with that. Let's try something else. Let's say I put the red into blue, and green into red, and blue into green. Cross-patching in really creative ways. Boom. All right. Let's see what we can do if we play with these. Very cool, my friends. We're getting those crazy 60s psychedelic colorizing effects here. Pretty retro, but pretty beautiful. And this is very clean, actually. Proc is going to really kind of step lightly on your signal. It's a fast module. And if you use the RGB mini snakes from LZX, you're not going to lose a lot in terms of detail. I do recommend those mini snakes. They look flimsy, but actually that's a good thing. If you use actually high quality cables, paradoxically they'll be worse because they're going to filter out a lot of the high frequency stuff. And if you're especially working in high definition video formats, you certainly don't want to filter out any of that. It'll make your images soft. All right, I could play with this all day because this is so much fun, but you get the picture here. We're able to do crazy stuff by patching RGB to, in this case, some completely different color space. Boom. Now, getting back to sort of the essential basics of how Proc works, I'm going to put my patch back to a standard red, green, and blue, red, green, and blue in and out, just so we don't lose our thread here. So we're not cross-patching, we're just changing up the red, green, and blue values. If we want to do a negative, as I was saying before, we need to invert and also bias. So I'm just going to neutralize these green and blue channels to start with. So here's red. All right, so if red was passing more or less transparently, we would do this. We would have our gain set to full or +1 at approximately 5 o'clock. And then we would set, of course, our bias to neutral or 0. We're not biasing up or down. Okay, so let's say we want to create a negative. So we'll bring this attenuverter down to its minimum. As soon as we cross that 0 line, we get nothing. So we have to additionally bias up in order to get that negative effect. So we can do the same here with green, boom, and blue, and bingo. We got our photo negative, and once again, I can do that wipe and compare it to the original. So there's your straight up photo negative. Awesome. Okay, so far we have only been adding a signal to the bias. We're adding an incoming signal to that bias. But now let's talk about adding two signals and then potentially adding the bias as well. So I've got my red, green, and blue going into the B inputs. I'm going to switch those over to the A input. And that's because I want to illustrate our ability to subtract or use the proc as a VCA or voltage controlled attenuator. Okay, I'm going to restore these back to neutral to start with. So right now at this point, I should be getting just an ordinary color image. I'm not attenuating, I'm not inverting, and I'm not biasing. And it's not going to be exactly the same color as it would be unmodified through proc because of the sort of messiness of these knobs. But again, that's kind of the beauty of analog, that we can't control it as well. All right, so let's say we take some signal. We want to subtract that from this picture. And I've got a dual shape generator here. Let's take a look at this wide view here. So I got my DSG. I'm going to take a signal out of that DSG. Let's say the absolute value of channel A. And I'm going to plug that into my proc input. So let's bring that back up again. Patch into the top input. And that's going to flow through, of course, into the green and blue channels. And now let's play around with these knobs here. We can reduce the intensity, just inverting. And at this point, we're subtracting that DSG pattern from the original image. And we can also, of course, bias that, exaggerate that, get a different result. So there's your voltage-controlled amplifier. And we can change that, of course. We can say, well, instead of making the center of the screen positive, in other words, we can see the image there, we can invert that. Now, of course, we can do that directly on DSG3 itself, but let's just pretend that we couldn't. If we had some other image, like a video image, and we wanted to invert the subtraction, well, guess what? We would just increase these values, bring the gain up, and then bias that down. So in this situation, what we're doing is we're adding A plus B, and that gives us a value potentially of 2 volts. And that is why proc is known as a summing amplifier. It can't amplify A, it can't amplify B, but the result of adding A and B requires an amplifier that can push up to, in this case, 2 volts. But then we're biasing that whole business down by 1 volt, bringing us back into a legal range and not clipping anything. Whereas if these were set to 12 o'clock, we would see that we're actually blasting out. We're losing detail in the brightest parts of our DSG pattern. Coolness. All right, there's your VCA. And of course, we can make all kinds of changes to the DSG settings and get different patterns. And that, of course, is a static ramp. It's not moving. But needless to say, if we had a moving video image, we'd be able to see that result here. All right, so there's our VCA. Another application of that VCA would be, let's say we wanted to alternately change the brightness of those different channels. And the Baja oscillator is perfect for that. And I've got 3 of those actually, because the Baja is so amazing. So that, of course, is from Brown Shoes Only, or the updated version of that, which is Video Headroom Systems. And the beauty of the Baja oscillator is that it is a tri-phase oscillator. That means instead of a quadrature, it allows us to take 3 versions of that sine wave, which are all out of phase with one another equally. So I got my Baja patching that up. We're going to put that here into the other input of Proc. And we're going to alternately attenuate the red, green, and blue channels. Let me bring the frequency of Baja down. So we're fading between the red, green, and blue channels. Awesome. And of course, same rules apply. We can invert that, get a different pattern to our Baja oscillator modulation. Pump all these up, see what we do. All right, so there's Baja acting as a voltage-controlled attenuator, but we're also biasing up. So we're kind of adding a couple of colors together at once because those sine waves overlap a little bit. And of course, we could cross-patch this. We don't have to patch, any particular phase into any particular channel. Right now, what I've got going is I've got the phase 0 output of the oscillator going into red, 120 degrees into blue, and 240 degrees into green. Cool. All right. Pre-processing a signal. What I've got here to illustrate that is the triple function generator from reverse landfill. And this uses the classic Dan-San-Dean function generator circuit, which acts like a video equalizer, you could say. We can adjust the brights, the mid-range, and the darks all independently on each channel of this triple function generator. I'm going to take the output of Proc and plug that into the input of the triple function generator. And why? It's so that we can modulate the input to the triple function generator, because the function generator does not have any control over the strength of the input. It just has an input and an output. So let's take a look here. So now, if I adjust the frequency of my Baja oscillator and increase the amount of modulation from that Baja oscillator, we're going to start to see some crazy stuff. All right, I'll reduce the frequency of Baja oscillator a little bit so we don't induce any epileptic seizures today. And let's set the inputs of channel B, which is coming from the Baja, to more or less half. And then we're also going to bias everything down. So what I'm trying to do here is get the maximum dynamic range between Baja oscillator and the original picture, the original image. Maybe even bring Baja oscillator up some more. All right, I'll bring that all the way up to its maximum. So we're getting maximum modulation from Baja oscillator. And then we're taking all of that, the addition of the Baja oscillator and the original image, and biasing that down a little bit in order to bring that into the right range. All right, and if we increase that Baja oscillator frequency up into video range, now we're getting this really cool effect. The result we're getting here from the function generator is dependent on 2 things. Number 1, the tri-phase oscillator, which, as I mentioned a minute ago, gives us the red, green, and blue channels offset from one another by the same amount. And then the other dependency here is, of course, Proc, where we're able to add the video signal and the Baja oscillator and also adjust their overall volume or intensity by biasing it down. That goes directly into the function generator, and that gives us this lovely effect of our scrolling psychedelic colorization. Cool. And of course, we can compare that to the original again and see how radically different it is. And that is the beauty of video synthesis, my friends. We can take a basic image like this photograph of Edinburgh Castle and completely manipulate it and turn it into something utterly different. I want to finish up by using Proc as a versatile mixer in which we can take the output of one channel and plug it to the input of another channel. and daisy chain those channels to add more than 2 signals. I'm going to add the 3 signals of red, green, and blue together in order to produce a single luminance or grayscale image. But because I have the ability to adjust the proc controls, that means I can get my own custom version of a grayscale image. You probably know that the luminance or Y channel in component video is derived from the red, green, and blue channels. They are combined in a very specific ratio that sort of matches the way our eyes perceive the brightness of those various wavelengths of red, green, and blue. Okay, but in the early days of film, the red wavelengths didn't really affect the film. It wasn't sensitive to red. And that is why dark rooms use red light. And that is also what gives old-timey photographs and films their specific look of very high contrast. And I'm going to emulate that here. I've plugged the red, green, and blue channels of my video image into the B inputs of Proc. And I'm going to take the output of this third channel. That's going to be my final output. I'm going to plug that into my encoder. Now, right now, it's not going to look like anything because we haven't really changed anything up. But let's say I increase this blue. Okay, so I'm adding blue. Now, we won't see anything if we change these green and red knobs because they're not outputting to anything. But we can quickly rectify that. I'll take the red output and plug it into the A channel of the green input. And I'll take the green output and plug it into the A channel of the blue input. Okay, so once again, the patch here is we're plugging red into the B input of channel 1, taking the output of channel 1, plugging that into the A input of channel 2, adding that to the green component of the picture, taking that output of channel 2, plugging it into the A input of channel 3, and then adding the blue component via the B input of channel 3. And now we can add all 3 of those signals together. So adding red, green, and blue, we can see that it's overexposed. So in a traditional Y signal, we're going to get almost all green. I'm going to dial the green down a little bit. We're going to get just a little bit of red and very little blue, if any, really, like 11% blue. So this is kind of more or less a Y signal, what we're seeing here. Okay? So that's, good enough, I guess, if all we want to do is get a Y signal. But of course, we have a lot more power than that. I'm going to get a sort of tin type look here, dialing that green down a little bit, bring the blue way up, and actually bring red into negative land. We're actually sucking red out of the image. And play with this, see what we can get. Maybe a little bit less blue there, maybe only half blue. I want to be able to see the sky there. Okay, and of course we can play with the bias as well. Bring that into sort of the artistic range that we're looking for based upon the tones in the original image. So there's my tin type or old-timey photograph. And I can do a wipe here and compare that to the original full color image. We can see that we've made some radical adjustments here, giving that a very old-timey antique look. Cool. So that's how we can daisy chain the channels of Proc in order to achieve a specific artistic result. And of course, as I said, this doesn't have to be an RGB. It could be anything. We can add control voltages. I haven't actually used the A input of channel 1 because I wanted to be able to adjust the values of all 3 channels. If I did plug something into here, then we would add 4 signals together, but we wouldn't have control over the intensity of that signal going into the A input of channel 1. All right, that's the rundown of Proc and some of the things that we can do with it. If you have more ideas, I'd love to hear them. I hope this is just the first in a series of videos talking about the tools and techniques of video synths and the LZX modular standard. Thank you very much.